Today, software touches every part of our world. It's not just in front of my computer, but also influences how I interact with my phone, to my car, gaming systems, and consumer devices. My name is Jeff Wayne. I'm a product manager in our fundamental AI research organization. What that means is that I try to understand customer needs and the eventual impact that we can bring to the world through AI. I'm here along with my colleague to talk to you about Code Llama and how it can be used to improve and create software that is integrated in every part of our lives. I'll talk to you about the landscape, its challenges, our vision of an AI-assisted software development future, Code Llama, an overview of the model, special features, performance, and a demo and tutorial at the end. While software is so pervasive in our society, we also recognize its challenges. Creating software can be pretty hard, as you all developers already understand this. First, you have to be trained in it. And second, for developers, most of our time actually isn't spent coding. It's spent digging into a code base we're probably not familiar with. What's the architecture? Where should I be debugging? What API is being used? Who set up the library like this? In the meantime, just making sure the code is well tested and robust. This can be challenging, frustrating, and sometimes a time sink. So currently, when we have these problems, our solutions may be somewhat limited. We could ask a friend, a colleague, hoping they have experienced a similar situation. We go online, search forums, as you all know, can be a hit and miss, depending on how unique or generic your situation is. And most often, you're on your own, and we just go through trial and error, try to figure out what the issue is. So how do we overcome this? Well, what if there's an AI expert programmer, pair programmer, that can help you and complement your workflow? Tasks that take a long time for a human to perform may actually be faster with an assistance of an AI pair programmer. For example, it takes a person probably a while learning a new programming language, where an AI model, having been trained across multiple languages, can assist you right away. Another example, reading and learning a large code base takes time, whereas a computer is probably pretty good at processing large blocks of text for you. So as AI gets better, we imagine a future where it'll be more productive and efficient for you to leverage a pair programmer, AI pair programmer, as you code. So if there's bugs, you can ask the model, hey, what's wrong with my code? Or can you rewrite this? Can you document and tell me what's happening? Or simply, can you complete the rest of this function? We want AI to help you with all these questions. Our vision is that AI tools can make software development much more productive. And in fact, developers also share the sentiment. In a recent survey, increasing productivity is seen as the biggest benefit that developers have in AI tools. The good news is also that a majority of these respondents, at 77%, also have a favorable and very favorable sentiment towards the use of AI tools. So that said, I think we're still in the early stages, and we want to make these tools even better. So to that end, last month, we released Code Llama. It's a code-specific model that can follow natural instructions, generate code, and assist in code completion. Code Llama is built on top of Llama 2, Meta's pre-trained LLM, and we took it and trained it even further on the coding-specific data sets and for longer, so it gets really good at code. It delivers state-of-the-art quality amongst publicly available code models that you can download and host. So we hope that this will improve your productivity and make it even easier while you're creating amazing software. Our vision and realization of Code Llama's potential also cannot just be realized by Meta or any one company alone. It takes a village, and an open one at that. That's why we've enabled commercial licenses for third parties to build on top of its foundation. The model weights are free to download, and we've also published a paper describing how it works. Code Llama will be enhanced by the community through improvements and also the applications that you all will pioneer. There will be ideas that we haven't even thought of internally, nor have the capacity to build them ourselves. And that's the influence the community will have of the future of an AI-assisted software development world. So speaking of the community, we've released Code Llama just 1 month ago, and it's been exciting to witness the incredible adoption since that release. This has been one of the most well-received launches of the year, and in the first week, of the launch, on GitHub, we saw over 9,000 stars of people favoriting this. We've also integrated Code Llama on Hugging Face, one of the most popularly used AI platform and library for the open source community. You can download the model on Hugging Face, and in just the first week, we saw over 100,000 downloads where the community has been improving with their own versions of Code Llama. So a couple interesting examples of that. We saw Find and Wizard Coder took Code Llama and traded on their own data sets, measured it on coding benchmarks, and were able to improve the correctness of these code outputs by another 20% on the test set. That's really exciting. Additionally, Hugging Face has also extended Code Llama to VS Code IDE extension, so you can start using Code Llama to assist in your code completion right away in that editor. So overall, we've listened to the needs of the developers, made Code Llama publicly available, and early results show that people are getting really productive use out of it. So we're excited to see what you do with it. But first, I'd like to hand it off to my colleague Baptiste, who will show you how it works and what it means to put into practice.
Thank you, Jeff. These models have the potential to change the way people code and learn to code. It's such an exciting moment, and I'm looking forward to digging into the details of Code Llama with you and showing how you could use Code Llama in practice. My name is Baptiste, and I'm a research scientist in our fundamental AI research organization. We have 3 models in the Code Llama family: Code Llama Python, and Code Llama Instruct. Code Llama is what we call our base model. It is trained from Llama 2 on 500 billion additional tokens related to code. It supports popular programming languages such as Python, C++, JavaScript, Bash, and many more. It has a lot of general knowledge about programming and can either be used directly or fine-tuned for tons of use cases. Code Llama Python was further specialized on Python and truly excels at Python code generation. Code Llama Instruct is actually designed to be used differently. It can follow instructions like ChatGPT and Llama 2 Chat can. Basically, you can ask it any question, for instance, how to generate a function, how to update your code to a new version of the library, or how to debug your code. Code Llama Instruct will follow your instructions and answer. Code Llama Python, and Code Llama Instruct form our family of Code Llama models. The base and Python models are designed to be used for code completion, for instance, in an IDE, and the Instruct version was designed to power Code Assistant chatbot. All the Code Llama models are released with a license allowing for both research and commercial use. And these models come in 3 different sizes, with 7 billion, 13 billion, and 34 billion parameters. Models of different sizes can basically be used for the same task, but smaller models are faster and generally easier to use. The 7B model can easily be run on a single GPU or even on a CPU on a laptop, and it generates answers very quickly with very low latency. So you may wonder, why would you want to use the 34 billion parameters model? The answer is that while it is slower, it's also more robust, and it can generate better code. It can still generate answers faster than you can read them when running on the right type of hardware. And you can actually start with the smaller models to test Code Llama in production and upgrade to the 34B model later to get the best possible performance. So in practice, smaller models can be run on laptops and are often used for tasks where latency is critical, such as code completion in an IDE. And here are a few details on training the base Code Llama. In terms of compute, training the base model is by far the most costly part. We start with Llama 2, which is important because we estimate that we will have needed twice the compute resources to get the same performance if we started from scratch. And it's a big part of what makes Code Llama a great model, despite it using less compute than other models out there. We call it the base model because it gives all of our other models their basic code understanding and programming capabilities. We also added 2 new features to Llama 2 so that Code Llama supports more use cases for code. The first one is long context support, allowing to use context from many different files at the same time to generate the code that fits in your code base. We support up to 100,000 tokens, and it corresponds to about 8,000 lines of code. Many competing models can keep the context of a single long file. And imagine, for instance, that you need to add a function to a large file of, say, 500 lines of code. So models handling only 300 lines of code will lose some of the context, such as the imports or some of the functions that are defined in the same file. With Code Llama, you can take the entire context of your file, but you can even add a lot of context from other files in your code base, or even some documentation in order to generate the best code for your code base and your use case. And for comparison, many of our competitors, as well as Llama 2, support context of up to 4,000 tokens only. With Code Llama, we bring a 25x increase to the amount of context that our model can use. The second feature that we added is infilling. The reason is that most programmers don't write code linearly, starting from the top and going to the bottom. Infilling allows Code Llama to support many real-world use cases. It means that it can generate code in the middle of a file using the context coming both before and after your cursor. In this example there, it can generate a class definition from an example of usage of this class that comes after in the main. I will present some numbers in the following slides, and let me first explain to you how we benchmark code generation models. A canonical benchmark for that is called human eval and consists in completing functions from their docstring and signature. So here, let me walk you through an example. Code Llama is asked to generate a way to compute unique with a list argument, and we're also given the docstring. And it needs to generate the highlighted code, which is a return of sorted of list of set of L. And then we can test the result using unit tests. And this figure there compares Code Llama to Llama 2 and to some of our competitors on such a multilingual generation benchmark. As you can expect, larger models, so those that are more on the right, perform better for both the Code Llama and the Llama 2 families of models. You can see that because they are higher on the y-axis, which shows the performance. And our smallest model, Code Llama 7 billion, already outperforms Llama 2 70 billion on code, even though it has only 1/10 of the parameters. It is also roughly on the same level as Codex V1 and StarCoder, which is the previous best open model, despite having less parameters than them. When it comes to our 13 billion and 34 billion models, they clearly outperform other open models for code generation. In this example there, we will test Code Llama Instruct 34B, which is our most powerful version of Code Llama and which was trained to follow instructions. Here we'll ask the model to generate a simple version of the Pong game in Python. To do that, it will need to first understand the assignment and also to make some design choices, such as choosing the keyboard keys that are going to be used to move the paddles. And it will also need to generate correct code. So as you can see there, the model generates the code as well as some explanations. And it generated this code in just a few seconds. And now if you execute it, you can already start playing this game that you generated on the fly. Then the nice thing is that you can also take this code, copy it, and modify it to fit your exact preferences. And you can even ask Code Llama to modify it for you in chat mode. In this example there, we'll show how Code Llama can be used in VS Code. And here we are going to use the base model using the Hugging Face VS Code plugin. It's very easy to install and it supports the base Code Llama 13b. For this demo, let's imagine that we are a data scientist and we need to get a data visualization for housing prices in the London area. We just know that the data is in a SQL database called housinglondon.db and the name of the table. And let's say that we have no experience with Python, so we don't want to write any code ourselves, but we'll just prompt the model to do what we want. So here what we want to do first is to read the data from the SQL database. So here we prompted the model to do just that with a comment, which also gives the name of the table and of the database to read. Code Llama manages to import appropriate libraries and to connect to the database. And now we prompted to read it into a pandas data frame to make it easier to work with. And we also want to print the names of all the columns in order to give them to the model. So here we ran the code, got the column names, and we want to add them as a comment so that Code Llama can access it and so that it knows what it can do. Okay, so now that it's done, we can simply ask the model to plot the housing prices. Here it comes up with something reasonable, and you can execute it, visualize the plot, and you can see that it isn't very readable for this particular data set because they have the very long tail of expensive properties that makes it very difficult to visualize the bulk of the properties in London. So what we can do is that we can prompt the model to correct it by removing the properties sold for more than £5 million and also to increase the number of bins. So that's what we do. It makes these changes. And if you execute, you can see this updated plot in which the bulk of the properties is much easier to visualize. So now let's do something that requires a bit of computation. Let's plot the price per square foot for properties in London. We need to compute it first as price divided by area, and Code Llama can find the right fields thanks to the command that we put above. So here is a plot. It looks similar to the price distribution, and here you can see that most of the properties were sold for a bit less than £1,000 per square foot. Okay, so now we'll try something a bit more complicated. Here, we ask Code Llama to compute the average price and price per square foot for each house type, and also to plot them together and not one after the other. It requires to do a group by operation, and Code Llama does that. The plot that we obtained there shows, for instance, that studio apartments that you can see on the right of the plot are the cheapest house type, but they are actually quite expensive per square foot, which makes sense since studios are small generally. And penthouses that are just on their left are the most expensive and also the most expensive type of property per square foot. Okay, so now let's look at what happens if we visualize something with many categories, such as the price per city or county in the London area. And here you can see that we get something reasonable, but the city names on the x-axis overlap, and it's unreadable. So we can prompt the model to correct it by writing the names vertically. So here we do that, and it manages to do it by doing a rotation on the x-axis. And you can see here that the prices are shown vertically, And so, for instance, you can see that on the left, this bar corresponds to the city of London itself, and that the most expensive town in the London area is called Oxshott, and you can see it towards the right of the plot. So here we've done some simple data visualization on this dataset without having to write any code ourselves. And of course, Code Llama is not limited to Python data visualization use cases. You can actually use it with any common programming language and for many use cases. I also want to remind you that you can download these models and run them locally, completely offline. So it means that you could have a local code assistant that doesn't require any internet connection. Code Llama could help you even when you're on the plane and can't access the documentation or online forums. Okay, so now I'll give you a bit of time to scan this QR code if you want to get more resources on how to run and fine-tune Code Llama. You will find some links there to some awesome third-party tools and libraries that were built by the community after the release of Code Llama. We also added some links to open source projects providing code to fine-tune Llama or Code Llama.